Okay, we're having a look now at question 7 from set 13. In this question, an environmental chemist is conducting research into highly alkaline solutions found in a drain near a concrete batching plant. Batching, incidentally, just means a mixing plant, and so it would be a place where concrete is being made up. The concentration of the solution was found to be 0.236 mole of hydroxide ion, and the runoff was found to have a concentration of 0.156 mole. And so we're told that the chemist mixed 200 millilitres of the solution from the drain. So let's go check that out again. Concentration of the solution from the drain was this one, okay? And he mixed the 200 millilitres with 300 millilitres of the runoff. And remember that it was the runoff that we were told is 0.156 moles per litre. You were asked to calculate the pH of the resulting solution. So we're dealing with hydroxide here. So we're going to have to take a strategy. We're going to have to find the concentration of the hydroxide in this mixed solution. We're going to have to figure out its pH from that. So, concentration. We know that concentration is equal to the number of moles divided by the volume. We've got two things that we're adding here, and we've got two volumes that are additive, they say. Okay, which means that 200 mils and 300 mils equals 500 mils, which does happen in this particular case. Okay, so we're saying 0.236 moles a litre minus 1 times 0.2 litres, okay, is added to 0.156 moles per litre, okay, times a volume of 0.3 litres. Okay, so let's put brackets around there to make it nice. Okay, nice and nice there. If we add those two together, we're going to find that that is 0.0472. And to that we add the 0.0486 moles. And if we do that all together, we should come up with a value of 0.0936 moles. Now, you can't stop there, because that's how many moles we have, and that tells us this N value that we're after. What about the V? V is very simply additive. It's 0.2 plus 0.3 equals 0.5. 0.5 litres. So we've got that many moles in half a litre. How many? We just double it to get the number in a whole litre. So therefore C is equal to 0.0936 on 0.5, and that comes out to a value of 0.1872 mole per litre. And that's mole per litre of this hydroxide ion. Okay, now we've got somewhere. So we've got a concentration of hydroxide ion. We're asked to find what the pH is. Now we know to do that first, our steps are 1, find H, and then 2, convert to pH. Okay, so we use our ionization of constant of water. The hydrogen ion concentration is going to be equal to Kw divided by the concentration of hydroxide, which is going to be equal to 10 to the minus 14 at this temperature, divided by 0.1872 or 1.872 times 10 to the minus 1. If you wanted to do it that way, it wouldn't matter, but that actually gives us a value of 5.34, 5.342 I think it was, times 10 to the minus 14. Hunky-dory, all very good. This is mole litre H plus. Now, we know from our old equation that pH equals negative log of hydrogen ion concentration, easy, far too easy, equals negative 1 times log of 5.342 times 10 to the minus 14. When you crack that through your calculator, you should get a value of 13.27, which, since we're dealing with 3 significant figures here, let's make it 13.3. Underline it, make it beautiful so that I can see it when I go look at it marking, and that is absolutely all you need to do. That is part A done. Bit of a song and dance. Just review the strategy if you don't mind. We found the number of moles in each of the two samples. We divided them by the volume to get the concentration of hydroxide ion. We used the equilibrium constant to find what that was in hydrogen ion, and then we used the pH expression to fill out the pH. Simple, nice, simple maybe, but very, very tedious, but nonetheless that's what you need to do for full marks. Let's have a look at the second part of the question. We're asked B, what volume of 1 mole per litre hydrochloric acid does the chemist need to add to the mixture to neutralise it? So neutralisation, just so, I need to select my layout. No, don't be like that, you horrible thing. Neutralisation is very, very simple. Aha, hydrogen plus hydroxide ion is going to make H2O. And neutralisation occurs when those two numbers are equal. So what we need to make neutral is exactly the same number of hydrogen ions as hydroxide ions. Now, the number of hydrogen ions that we have, hydroxide ions, in 1 litre, we already have figured that out as 0.1872. That's what moles per litre means. Okay, so what we now are going to do with this particular one, we need the same number of hydrogen ions. So therefore, let's need same H plus ions equals 0.1872 moles per litre. Sorry, minus of them. Okay, now we've got 1 mole per litre of hydrochloric acid, and we're asked how many we need in a litre. That's the question. It says how many per litre. So what we simply do is we're using our volume. If we rearrange our old friend, is equal to the the number of moles divided by the concentration, which in this case is equal to 0.1872 divided by 1, which equals 187 millilitres, or 0.187 litres. And that's how to tackle the question. Most of these questions really involve knowing your 2 or 3 relationships with pH. pH equals negative log, hydrogen ion concentration, how to calculate the hydroxide and interconvert them using the equilibrium constant, and then simply doing these very, very simple calcs on based on N equals C times V, or rearrangements of it. And that, to its 3 decimal places or significant figures, is how to handle that type of question. Hope you found it helpful.